Hey guys, so in this video I'm going to explain to you dependency injection and why it's useful and how to use it within a Golang project. So to start, here we have a very simple Go project, and let me explain what's going on. So here we have a main function which instantiates a logger, passes through an API service, and then just calls something on the API service. So if we look at our logger, it's very basic. So we have a new console logger. Essentially, this prints out to our console and a function called log. And then within our API, imagine here we have a lot of things like, different GET request, PUL request, or whatever you want. But in this specific example, the API service requires a logger. So we're passing in a console logger, and then we simply create a GET function that logs something and returns whatever data we pass through. Very basic, very simple. So this works if that's everything you need. But imagine a case where the type of logger changes. So instead of doing console log, like logging to our console, our requirements are now we want to log to a file, for example, or maybe we want to log to a third-party service, like through an API request, like Datadog or something similar. So let's say we want to do that. So let's go to our logger and let's just create a new logger. Let's call it file logger. So here we create a new file logger and then we simply log things. Okay, so we have a new logger. So now in order to update things or like use this logger, we want to go to our main. And so we know that this logger is no longer valid because we have different loggers. So in order to change this, we first need to do logger, or maybe let's call it file logger, and then file logger. All right. Now here you see we already have a problem because our API is tightly coupled with this logger, meaning that this logger here is not the file logger and it's very specific. So to fix it, we have to change this code as well. And we have to say something like file logger is actually the file logger here. And then we should change this one as well to file logger. And this one to file logger. And this one as well. So you already see the problem here. Like if we have another one yet, like let's say a third-party logger, then that becomes a problem because now this is a very simple and a very small project. But imagine this is like a really big one and you have a lot of code that depends on this logger. Suddenly you have to change this every single place. And that's because the code is tightly coupled. And that's really the heart of the thing with this dependency injection. The whole point is that you decouple your code. Things are not dependent on each other anymore. Instead, you inject some of that code or some of that logic in a way that makes it really easy to swap. So how do we fix this? Imagine like we actually want to have multiple types of loggers and we want to support that. So let's go back to our logger first. And let me comment all of that and just rewrite some of these things. So we know we don't want to have a specific logger like this, and we want to make this a bit abstract, right? So what we can do, type logger is an interface. And here we can say log a message. So we don't have an implementation yet, and we just defining an interface, a contract that will enforce any other type of loggers to kind of have a log function. And now let's say we have a type called console logger, which is a struct. We create a constructor for it, and then we log it. Now, this console logger is an implementation of this interface because it has a function called log, right? So every time you have a function, any structure that has a function called log on it is implementing this logger interface. And the same will work for our other logger, which is a file logger. Same exact thing. Like that. And now we have another type of logger. Cool. So now if we go back to our API, how do we change that? So instead of file logger, what we can do here is like, let's just say logger and use logger here. And this logger is actually the interface. Notice that we're not specifying a specific implementation. We're just making it a contract here. We're passing an interface. So instead of passing a implementation, what we can do here is say logger, which is an interface, and do logger here as well. And then go all the way down and say a.logger.log and whatever data, for example. And here, like this. So yeah, now this is gonna abstract. We don't know what the logger type is, and we're already like doing things with it. So we're calling this function log, which is coming from this, but we still don't know what the implementation is. So now we can pass any type of logger to this service. So if we go back to our main function, notice that this is working, and we can like swap it just like that, and maybe change this to logger, and it will still work. And the reason is because this new API service accepts any logger that implements the logger interface. And in our case, we want console that works. So if you want, let's say, a file logger, let's rename this to, let's say, logger, comment this one. Now this still works. So that's really how dependency injection works. So you want to be able to inject some sort of a dependency to the service without having to change a lot of the code. So it's easy to swap. And you can even go back to your logger here and create even one more logger called, let's say, third party logger. And that, let's say, this connects with some sort of an API. Same exact thing. So it's so easy now. You can just go to your main and create a new logger. Let's just comment this one and say new third-party logger, and that will still work. And that's the powerful thing about dependency injection. It decouples your code in a way that you can swap different implementation without having to change a lot of code. And this specific example is very simple. Obviously, you see that you have 3 files here, but imagine this project is really big. You will start seeing how powerful this thing is. You can just swap implementations. Here's an example. Let's say you're using Stripe for your payments, and your whole code is built in a way that is tightly coupled with their API or with their SDK maybe. A requirement comes, and now you have to swap the Stripe API to like some other payment gateway. Now you have to change your code everywhere, where if you actually using dependency injection, all you have to do is just change the provider, create the payment for you, right? And you just pass it in as a dependency or inject it in this way. So that's kind of the idea behind dependency injection, and that's just how to swap implementation. But also it's very helpful and very useful when it comes to testing. So let's write a test for our API. And here, let's just say package main function test my API and T testing. Yep, that should do it. All right, so here we create a third-party logger. Actually, we don't want a third-party logger here. The idea is we want to mock this, right? So we want to create a mocked logger. Why? Because maybe this third party requires an actual API call, and we don't want to do that. So we need to have a mocked version of this just to simulate that this thing is kind of working. So what you can do is create a type called mock logger, which is a structure. And instead of making an API call, maybe you can just add to an array and check if this thing is inside of the array. So what we can do is l dot, we can actually pass in a message here, which is an array. And here, yeah, that's pretty much what I want. Essentially, I'm appending the messages that I'm sending. I'm trying to log to this message array. So now, instead of creating a new instance of this third-party logger, what I can do is just create the mocked version of it. So I can say mock logger here and just pass it through. It's still going to work. This mock logger is implementing our logger interface. So it's still going to work, right? So now we know that this API is going to return something. We know it's going to return hello world in this case. So let's go back here and create response, for example, and then say that our response should be equal to this hello world. We can obviously use some libraries for this. For example, go get. All right. So now we have it. Now we can just use it. So instead of doing that, assert equal this guy. There you go. Now the test passes. And even if we run our code, for example, go run dot, you see it works. So that's the other thing about dependency injection. You can essentially use it to create mocks. In this case, like we're creating a logger, a mock for the logger, and then we can use that. And this is helpful because if, for example, the logger requires some API calls and things like that, and you don't want to really do these things in your tests, you can just create a mock for that. So imagine another scenario, for example, where you're mocking an API. You just don't want to call the APIs, but you want to kind of simulate that. And that's how you do that here. You create a mocked object of this, and then you inject it to whatever service or code you're using, and then you just use that. So that's how dependency injection works within tests as well. Very helpful for testing. Now, there are libraries that you can use to kind of do more things, but in the most basic form, that is what dependency injection is all about. It's essentially a way for you to swap dependencies for different services or within different services without having to change a lot of code, as easy as you can. And then within tests, it's very helpful because you can create mock objects or mock structures, and then you can use them to simulate the certain thing you're trying to inject. So that's pretty much what dependency injection is. I hope you found this useful, and I'll see you in the next one.